Hi guys, this is Mohan. Welcome to Exception Handling in Java session 2. In this session, we are going to discuss how to handle the multiple exceptions, how to use multiple catch blocks, and what are all the precautions we need to take care while using multiple catch blocks. What is nested exceptions, how to handle them, finally block, what is the purpose of finally block, when it will be executed, when it will not be executed. These are the topics we are going to discuss as part of the session 2 guys. Let me move on to my code. Guys, this is my code where I have written one print statement away and followed by try catch, then the remaining code. In my try block, I have a piece of code int k is equal to 12 by 0. As we all know that it will throw the arithmetic exception. Then I handle this using catch block. But it is not always true that your code will throw only one exception, right? In real time, you may have n number of lines here like this. A string s is equal to null. On top of it, I'm calling the method. What if this happens? See here my code, that is line number 6 to line number 8, may throw two exceptions, one arithmetic, one null point exception. If I handle only arithmetic exception using a catch block, if this throws the null point exception, it will break my code, right? So what I need to do is I have to define one more catch to handle the null point exception. Then dot print stack trace. If this throws the arithmetic exception, first catch will take care. If this throws the null point exception, then my second catch will take care, so that my code will execute smoothly. Let me show you guys. Start arithmetic exception and remaining code. Guys, I have a doubt here. See, my code line number 6 to line number 8, it may throw two types of exceptions, one arithmetic, one null point exception. But when I execute it, it is throwing only arithmetic exception, right? What will happen to my null point exception? Why it is not throwing? Guys, the reason is in try block, if one piece of code throws one exception, then the remaining code will not be executed. In this case, line number 6, int k is equal to 12 by 0 is throwing arithmetic exception. So the remaining code will not be executed. Directly it will come to the catch block and this catch will handle this exception, then it will go and execute the remaining code, which means it doesn't matter what is the code wrapped inside of try block, how many possible exceptions it may throw. But if one exception thrown, then it will not throw the other exceptions, which means at a time only one exception will be thrown in entire block and the corresponding catch will be executed. Only one catch block will be executed at a time. Let me repeat guys. How much of code you have, how many possible exceptions it may generate within a try block, it doesn't matter. If it is throws one exception, then it will not touch the other exceptions. It will not generate the other exceptions and the corresponding catch block will be executed. So at a time only one exception will be thrown by try block and only one catch block will be executed to handle the corresponding exception. That's what here. At a time only one exception occurs and at a time only one catch block will be. At a time only one exception occurs and at a time only one catch block is executed. Guys, from until Java 6, developer has to define one catch block for each exception. But from Java 7 onwards, they made something like this. That is, one catch block can handle multiple exceptions. Guys, see this here, one catch block is defined to handle both arithmetic and null pointer exceptions. Suppose if this piece of code is, and now I am executing the code. This piece of code is throwing arithmetic exception. Then who is handling this is my catch block. Let me modify this, guys. Now it will not throw the arithmetic exception, but it will, when it comes to line number 8, it will throw the null pointer exception. Then start remaining null pointer exception. Now this piece of code is throwing the null pointer exception. Then who is handling this null pointer exception is again the catch block defined at line number 10. So one catch block you can use to handle the multiple exceptions from Java 7 onwards. This is one of the beautiful features of Java 7. But be careful, guys. If you want to see particular exception which is specific to arithmetic exception, then don't use this and define separate catch blocks for each exception. Though that way you can see the specific exception for specific message for specific exceptions. Now let us move on. Guys, you need to take care of few more precautions here. I'm defining arithmetic exception and runtime exception. Two catch blocks, one for handling the arithmetic exception and one for handling the runtime exception. Guys, these are not at the same level. So whenever you keep like this, arithmetic exception and runtime exception, here arithmetic exception is a subclass of runtime exception. So always more specific should come first than more generic. If I keep this runtime exception at line number 10, that is at this place, it will handle all the exceptions, right? Superclass can handle the subclass exceptions, meaning let me show you guys. If I keep like this exception class, this runtime exception also will handle the arithmetic exception. So always when you are using multiple catch blocks, keep in mind that most subclass should come first, then superclass, which means more specific exceptions should come first, then more generic exception. Here I am keeping a runtime exception and arithmetic exception. Always arithmetic exception should come first in hierarchy, then runtime exception, or otherwise it will throw the error. Why it is throwing the error is all arithmetic exceptions also will be handled by the runtime exception. Superclass can handle all the subclass exceptions, and JVM will never ever execute this catch block. This is something called unreachable code, and Java will not accept this kind of code. That's why it is throwing the error. Let us see this. See, unreachable catch block for arithmetic exception. It's already handled by the catch block for runtime exception. Guys, let me repeat. Whenever you are using the multiple catch blocks, most specific should come first, then most generic. If you keep most generic, that means superclass, it will handle all the subclass exceptions, and your JVM will never ever execute the subclass exceptions as I highlighted on the screen. So that piece of code is known as unreachable code, and Java won't allow this unreachable code. It will throw the exception. This is what we are discussing. All catch blocks must be ordered from most specific to most general, which means submost class should come first, then superclass. That is, catch for arithmetic must come before catch for exception. Guys, there are some scenarios where you may need the nested exceptions. This. Let me modify this code, guys. This is normal try catch blocks. If you define one more try catch inside of see guys, one try catch I am defining within another try block. This is known as nested try catch blocks. Why is this? Suppose your inner code may throw one exception, outer code may throw different exception. Here see guys, this string s is equal to my inner catch. I define string s is equal to null and I am trying to call the method. It will throw the null pointer exception and I am handling this. Print stack trace. This is the inner block, inner try catch. Then this is my outer try catch. Entire code may throw one type of exception, but inner try catch may throw different exception. Guys, if I execute this, it will execute start, it will go to try block, outer try, int k is equal to 12 by 10, it will not throw the exception, and it will go to inner try block, string s is equal to null, then it will throw the null pointer exception. We are handling the exception, it will not break the code. Then it will come to outer catch, it will not execute the outer catch, then it will go to remain statement. Let me show you guys. Start this one and it will throw the exception. It is handling the null pointer exception. It will not execute the outer catch, it's going to execute this. Guys, what if I am not handling the exception here? My inner block let's put this code here. Guys, this is the piece of code. Let me show you this. See this? My inner try block will generate the null pointer exception, but I am not handling it. I am trying to handle array in the out of bounds exception. Then who will handle this null pointer exception is outer try catch. If inner catch is not able to handle the exception, then at least outer catch will take care. In this case, that is true. See this? It is throwing the null pointer exception, but inner catch is not handling. Then it will go to this catch block, and this catch block will execute this program. See guys, start, null pointer exception, and remaining code. Guys, let me modify this code. I am modifying int k is equal to 12 by 0. Guys, can you guess the output now? Just pause this video and guess the output. So let me repeat once again the code. I have written one print statement, outer try and int k is equal to 12 by 0. Try block, inside try block I am generating the null pointer exception, but I am not handling it. And outer catch, here I am using multiple catch blocks, one per arithmetic exception, one per exception, and remaining code. Guys, what will happen here is it will execute the line number 4, it will enter into outer try, then it will go to execute line number 6, that is int k is equal to 12 by 0. It will throw the arithmetic exception. When it is throw the arithmetic exception, all these are the remaining statements in outer try block, and your JVM will not touch it, and it will go directly to this catch block, and it will handle this, then it will execute the remaining code. Let me execute, guys. I will show you this. See this? Start, then it's not going inside, it is handling this and the remaining code. That's all for nested try catch, guys. Sometimes a situation may arise where a part of a block may cause one error and the entire block itself may cause another error. In such cases, exception handlers have to be nested. Sorry guys. Let us see finally block. Okay, let me show you the diagram. See this? This is my program code, and there are two scenarios, guys. One, exception may occur and exception may not occur. First scenario, exception occurred, no. If exception occurred, no, then finally block will be executed. Means if there is no exception thrown by your code, then finally block will be executed. Let's see the another scenario. Your code is throwing the exception and you are not handling, then finally block will be executed. And your code is handling the exception, throwing the exception, and you are handling the exception, even then the finally block will be executed. Let me repeat, guys. I have a piece of code and writing the Java finally block. If there is no exception, your finally block will be executed. Yes, there is an exception, but you are not handling, then finally block will be executed. And there is an exception and you are handling, and also the finally block will be executed. So finally block will be executed under three circumstances. One, when there is no exception. Second one, when there is an exception but not handled. And third scenario, when there is an exception and you handle the exception. Let me show you the code, guys. I'm removing all. Int k is equal to 12 by 0. And remove the multiple catch blocks. Guys, before this, let me pinpoint one point I missed out. See, almost try either should be followed by catch or finally block, and try you cannot define alone. See this? It will throw the error. You cannot define try alone, you cannot define catch alone, you cannot define finally alone. Either try should be followed by catch or finally. Now here I am defining catch, right? So how it will work when you are executing this piece of code? If this throws the exception, then catch block will be executed. If this doesn't throw the exception, catch block will not be executed. But Java allows you to define something like this. So try followed by finally. So it is allowed. Suppose if it is throwing the exception, then finally block will be executed. If it is not throwing the exception, even then finally block will be executed, because finally block will be executed under all circumstances. So it is not advisable to keep the finally block after the try block, because you don't know whether the piece of code is throwing the exception or not. Always the finally block will be executed. Always the finally block will be executed. So the best practice is define catch block after the finally block to handle the exceptions, and finally block is entirely different purpose, guys. Whatever the important code, it has to be executed under all situations, like disaster recovery also. Keep that piece of code in finally block. Let me repeat once again. The important code which has to be executed in all scenarios, keep that piece of code in finally block. In real-time scenarios, let us say I am establishing a connection to my database. If exception occurred, I don't want just simply terminate my code, because before terminating my code, I have to close that connection to the database so that others will use the database. Similarly, whenever you are contacting the external resources, IO devices, and when you are opening the connection, make sure that before terminating, you have to close those connections. Such piece of code, such piece of cleaning code, such piece of closing the connections, you keep it finally block. That is the importance of the finally block, guys. Okay, let me go here. I'm going to write finally followed by this is what, guys, we're discussing. See, I have a piece of code, I have a try block, within I kept followed by something here, and then again followed by catch, then followed by finally, then remaining code. Let me go back and show you, guys. See how Java finally block will work is, the first scenario is this. I have a code where it is not throwing the exception, and your finally block will be executed. Let me show you this scenario, guys. I am writing a code which will not generate the exception. Now what is the output? It will execute start, it will come to try, it will execute int k is equal to 12 by 10, it will not throw the exception, it will not execute the catch block, it will go to finally block. Since there is no exception, it will execute the remaining code as well. See this, guys, start, finally, remaining. The first scenario is over. So finally block will be executed when there is no exception thrown. Second scenario, when there is an exception thrown. See, then there is an exception occurred, and I am not going to handle it. Exception occurred, guys, I am handling here null pointer exception. See this, it will execute start, then go to try. Within try, I have int k is equal to 12 by 0. It will throw the arithmetic exception. Are we handling this exception? No, I have catch block. This will not handle the exception. Then it will go to finally block. It will execute. In this case, it will not execute the remaining statement because we are not handling the exception. See, guys, here start, finally, and exception details. So this piece of code will not be executed. So let me repeat once again, guys. my code is throwing the exception and I'm not handling it, then also finally block will be executed. Third scenario, my code is throwing the exception and I'm handling it, even then it will execute the finally block. This is the one, guys. Within try, I have int k is equal to 12 by 0. It will throw the arithmetic exception. This catch block will handle it. It will go to finally block will be executed. But of course, since you are handling the exceptions, your remaining code will be executed. Start exception, finally remaining code. So that's all for finally block, guys. Finally block will be executed under three scenarios. One, when there is no exception occurred. One, second scenario is when there is an exception but we are not handling that exception. And third scenario, when there is an exception and you're handling that. All these scenario finally block executed. But is finally block will execute all the times? Will it never ever break? Yes, guys, finally block will not be executed under two scenarios. One scenario I can show you here. Whenever JVM encounters system.exit, in which block it is doesn't matter, maybe in try block, it may be in catch block, it may be in final block. Whenever JVM encounters system.exit, then and there it will terminate. Now I am executing this program. It will go to start, go to try block, int k is equal to 12 by 10, it will execute system.exit. Then at this line it will terminate. It will never execute the catch block, it will never execute the final block. See, start, it's not throwing any exception details because it is not going to execute any of these blocks. So do we need to keep system.exit only in try block? No. Even you can keep here. It's not executing anything. Even you can keep in catch block. Make sure that your catch block will execute. So in this case, what is the output? It will go start by number 5, enter into try block, it will generate the exception. This catch will take that exception, it will print this and it will terminate. See, start exception, then it is terminating. Even you can define this system.exit in finally block. In this case, what is the output? Start, it will throw the arithmetic exception, it will go to catch block will be executed, then we'll go to finally. Then the first statement in finally is, let me put one more statement. And you'll execute this and JVM encounters system.exit of 0 and it will not execute the rest of the statement, but of course other statement as well, that is remaining code. See this, guys, see this, start exception finally. So whenever JVM encounters system.exit or your server throws fatal error, then your finally block will not be executed. System.exit, you can write this code outside the try block, within try block, within catch block, within even finally block. This is about your finally block, guys. See this, if you don't handle the exception before terminating the program, JVM executes finally block. For each try block, there can be 0 or more catch blocks, but only one finally block. The finally block will not be executed if program exists, either by calling system.exit or by causing a fatal error that causes the process to abort. Thanks for watching this video, guys. Please subscribe to my channel and share the videos with your friends if you like it. Thank you so much.